Welcome back to the Finely Tuned Infrastructure podcast by Rhythmic Technologies.
We're continuing our look at some really deep shifts happening in software engineering.
That's right. This is part 2 of our series, AI and the Future of Software Engineering, a new path to senior engineer. And it's all based on a recent blog post from Rhythmic.
Yeah, and in part 1, we really laid out the core problem. AI is getting incredibly good at automating that, reliable mid-tier work, taking a spec and turning it into solid code.
The backbone of the profession.
And with that part getting automated, the traditional career ladder, it's basically breaking apart. The whole path that relied on years of that work to build intuition is just gone.
Which brings us right to the mission for today. If that training ground is gone, how on earth do we develop the senior engineers we need? The ones who can orchestrate these powerful AI agents.
Right.
And the blog's answer is that we actually have to look backward, not for some new high-tech solution.
It's a huge paradox, isn't it? The old way was, grinding out tickets for years. You'd absorb patterns, make small mistakes, build up what the post calls system intuition.
That was the engine for development.
Exactly. And that engine is being replaced. So AI is raising the bar for what seniors need to do, while at the same time, it's taking away the very tool we use to create them.
Okay, but why can't we just adapt, create a new boot camp for prompt engineering, or, get certifications for new AI tools?
It's a good question, but the blog argues that's not enough. Because the knowledge that makes a senior engineer a master engineer, it isn't something you can put in a textbook.
It's not codified.
Not at all. It's tacit, it's contextual, it's, constantly evolving. It's all tangled up in the specific history of the system you're working on. A decision that was smart last year could be a total disaster today because some API changed.
So a certification is useless for that kind of messy, real-world judgment.
Completely insufficient, yeah.
And that's why the blog says we have to turn to the apprenticeship model. It's what humanity's always done for these kinds of domain-heavy fields.
Right. You work alongside a master, you observe, you try things under supervision, and you get that immediate high-stakes feedback.
The blog makes a really direct comparison here, which I found interesting, to electricians.
It's a fantastic analogy.
But is it really a good fit? Programming is so abstract, electricians are dealing with, physical laws.
It holds up surprisingly well, actually. If you look at the core characteristics, electricians do highly specialized, domain-specific work.
Oh, yeah.
They need a similar problem-solving aptitude, and even their compensation can look a lot like a software engineer's. But the key is the training. You don't become a master electrician from a 6-month course.
Right, it takes years.
Years. As an apprentice working under a licensed master, you're learning by doing real work with real consequences. That's the model software has to adopt now that the basic code writing is handled.
So the whole journey is flipped on its head. It's not about creation at first, it's about critique.
Exactly. It's all about building that mental map of the system as fast as possible.
Okay, let's walk through the 4 stages the blog lays out. It starts with stage 1, validation.
Right. So in this first stage, the apprentice's main job is just reading AI-generated code, not writing it.
So they're a code reviewer, essentially.
A very critical one. They have to understand the original intent, catch those subtle bugs the AI missed, and, this is key, recognize when the code is technically right but contextually wrong.
Got it.
And by doing that, they build up a map of the code base way faster than they ever could writing it piece by piece.
So once they've developed that critical eye, they move on to stage 2, which is sandboxed generation.
Now they actually get to run what the blog calls the agentic flow.
Can you define that for us? That term is pretty central here.
Sure. The agentic flow is the whole loop. The human gives a high-level goal. The AI breaks it down, generates code, runs tests, tries to integrate it. The apprentice manages that whole process.
But in a safe environment.
Exactly. Bounded, low-risk areas, maybe some utility functions or isolated test suites. The stakes are low, the feedback is fast, and the senior engineer can step back into that validator role.
So they learn to steer the AI without breaking production. That makes sense. Then stage 3 broadens that out. Sub-agent rotation.
This is where the system-level thinking really starts to click because they're forced to see the system from all these different angles.
Not just code.
Right. They rotate through being the human in the loop for test generation, then for security analysis, then for checking the AI's documentation. They learn the specific ways these agents tend to fail.
They're learning the failure modes.
Exactly. It builds a complete system perspective, not just a feature one.
Which all leads to stage 4. Orchestration.
Hmm.
This is where they become what the Post calls a journeyman.
The journeymen can run that whole workflow on their own. They're responsible for the outcome. That means designing the scaffold, breaking down the task for the AI, providing the context,
And knowing when to follow the rules.
and more importantly, when to break them. And when they do deviate, they have to document it properly. That's what shows they're ready for that independent responsibility.
It sounds like a really solid pipeline. But the blog points out a big historical problem with apprenticeships.
It does. They fall apart when the masters, the seniors, don't want to teach or aren't rewarded for it.
Right. Mentorship takes a lot of time and energy.
It's expensive, so firms can't just expect it to happen. They have to value it, reward it, and actually measure seniors on their ability to teach. If you don't incentivize the master, you don't get the next generation of journeymen. Simple as that.
Okay, let's say the company gets that right. We now have this journeyman who's a highly effective orchestrator shipping features. What's the difference between them and the master engineer?
It's a fundamental shift in focus. The journeyman executes. The master maintains the system itself.
And that means maintaining the context, not just the code.
Yes. The understanding, the history, the constraints that make the code possible in the first place. The blog is really clear on this. A master's primary output is context, not code.
So what are they actually doing all day if not shipping features? The blog lists 5 critical non-coding tasks. First is shaping the scaffold.
Right. This is architecture, but for the process of building. The AI can write code, but it can't decide how to break down the work. The master defines the interfaces, the data schemas. They decide where a new piece of work even belongs. They set the rules of the road for the journeyman.
And that structure leads right into the second role, maintaining the record. We touched on this. The well-documented exception.
This is their core intellectual contribution. An undocumented deviation is like the cardinal sin of this new era.
Yeah.
The master has to write down not just what was done differently, but why. That history is dark knowledge to an AI. Without it, the AI will just follow the standard and cause a huge failure.
They also have to be responsible for allocating human attention.
Which is now the scarcest, most expensive resource you have. Human judgment.
Right.
The master decides where that judgment gets spent. They identify the choke points, the places where a small mistake could cascade into a disaster. They're basically managing human cognition.
And the fourth point brings us back to the pipeline, developing journeymen.
It has to be part of the job. It's non-negotiable. A master has to be able to explain their reasoning, to demonstrate their judgment in real time. That's how tacit knowledge gets transferred.
And finally, they have to be able to intervene when it matters. They can't just be an architect in an ivory tower.
No way. They have to stay hands-on enough to step in when something is truly new or when the AI just gets stuck. The Post notes that their authority to orchestrate comes directly from their proven ability to execute when they have to.
So if their contribution isn't lines of code, the metrics have to totally change.
Radically. The new metrics for a master are things like the velocity of the teams they work with, the quality of the engineers they produce, and the disasters they prevent.
How do you measure a disaster that didn't happen?
It's hard, but you look at the reduction in major security holes or the elimination of costly outages over time. It's the true value they create.
Let's zoom out then for the final section. What does this do to the overall labor market? The Post is pretty blunt that this means less overall demand for engineers.
It's inevitable that one master engineer can now manage the workload of what used to be a team of 5. That efficiency gain is huge, and it leads to what the blog calls a bimodal distribution.
2 groups.
Right. On one side, you have this very defined high-aptitude profession, apprentice, journeyman, master, clear expectations, clear path.
And on the other side.
A much, much larger group of people who use AI tools for software-adjacent tasks. They're writing scripts, analyzing data, building internal tools. They use code, but they aren't hired as software engineers.
So that whole middle layer of the profession,
Yeah.
it just empties out.
Pretty much. That group is forced to move. Either they skill up and get on that journeyman track, or they move to an adjacent role like product management, or they leave the industry. The era of the comfortable mid-level coder is ending.
The profession really transforms then, from a kind of creative craft to something more like a structured trade.
It's a sign of maturity, really. You'll see more formal apprenticeships, credentials that are tied to actual competence, standardized practices, just like the established trades. The core job is still translation, human intent to machine behavior, but engineers will be freed from what the Post calls the tyranny of code.
They'll be focused on the high-value business decisions instead.
Exactly. And the blog ends on a warning. This isn't science fiction. The transition is already happening. The firms that started building these pipelines 2 years ago are already way ahead.
That is a fantastic summary, and it leaves me with a final thought for you to consider. What undocumented deviation is lurking in your code base right now, just waiting to trip up an AI and cause a disaster?
A sobering thought. And that does conclude our two-part look at AI and the future of software engineering.
This entire conversation was based on a blog post published by Rhythmic Technologies, and the content, as it happens, was AI-generated, which kind of proves the point.
It does. If you want to read the full analysis for both Part 1 and Part 2, you can find them over at rhythmictech.com.
We look forward to having you next time.